Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And in studio with us we have Isley. And Isley, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-435-7. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And social media, Facebook, Instagram, Twitter, and YouTube.
It's a lot of stuff, isn't it? A lot of different ways to get a hold of us, right? If I needed to get a hold of you, how many different ways could I do that?
A lot.
A lot?
A lot.
You have a telephone? You have a number, right?
Yeah.
Do you have an email account? At school you do, right?
Yeah.
Right, so you have phone, you have email. Do you have any of that social media stuff?
Yeah, my parents probably do.
Oh my gosh, well, let's see, you have just as many ways to get a hold of you as we do here. How are you today?
Pretty good.
All right. Where do you go to school and what grade are you in?
I'm in 4th grade and I go to Stockton Elementary.
You're in 4th grade?
Yes.
All right. For some reason I thought you were in 5th grade. You're probably as smart as a 5th grade kid though, aren't you?
Probably.
But you're in 4th grade.
4th grade.
How's 4th grade going?
Pretty good.
What's so good about it?
I'm in oral language with my best friend and it's been really fun. We did student government together.
So are you doing a duo?
We're doing a duo.
Okay. Is it serious or humorous?
Humorous.
Humorous. So you're a funny kid.
Mm-hmm.
Oh, you like to do that kind of stuff,
Yeah.
right? How long have you been practicing that so far?
We've been doing it for a few weeks.
When is your competition?
Our competition, I'm not that sure.
Okay. But it's coming up.
Yeah, it's coming up.
Obviously, you've been practicing a lot
Yeah,
for
we've been
it.
practicing a lot.
So you also mentioned that you do student government. What do you do? What is that?
I'm my class representative, and I go to some meetings I go with my best friend,
Okay.
and she's the superintendent of ground.
All right.
So we do it together, and I get to go to the meetings.
And then you go back and tell your class what's going on?
Yeah,
with the
I
meetings
tell my
and
class
stuff
what's
like
going
that?
on. I ask them if I can tell them anything to bring up about.
Okay. So has there been anything that you've had to bring to the meetings that your classmates are concerned about?
Not yet.
Is there anything that you have been concerned about or anything that has surprised you at a meeting that you brought back to your class?
I brought back the thought of how soccer's improving.
And is it?
Mm-hmm.
So you
It
like
is.
that?
Yeah.
All right.
It's a lot
So
of
you
boys
like
play
going to school
soccer.
longer now because you're in 4th grade. You have to go
Yeah.
to school a little longer during the day now, right?
Yeah.
So you're all fine with that?
Yeah, I enjoy it.
Oh, good. What's the most enjoyable thing, like the subject or the topic that you like the most in school?
I think when we do science, it's pretty fun.
Okay. And science fair is coming up also. Are you doing anything with that?
Yeah.
And is
I'm
that
doing-
something that you do on your own or do you do that with other people also?
I do it on my own, but my parents help me with it.
Good. Well, it's always nice to have some help also, right?
Yeah.
Do you know what your project is? Have you started that yet?
Yeah, I've started it. Tomorrow I have to turn in the board.
Oh, okay. So you're
So-
just about done with it.
Yeah.
You need to get everything going.
Thursday is the day that the judges come in and judge it.
Oh, big day coming up then, right? So you're going to have to
Yeah.
answer questions and things?
Yeah.
So I'm going to give you one question right now to practice.
Okay.
What is your project about?
My project is about if you could mix water with the liquid in a flower, would it help cut flowers stay alive longer?
Okay. Well, you know, the Kern County Superintendent of Schools hosts the Kern County Science Fair. So if you do well at your school competition, if I'm not mistaken, you get to move on to the county competition. and then you'll be able to see other people from all around Kern County and the projects that they've done as well.
That would be pretty cool.
That would be pretty cool. Well, you know what? How are you doing some math problems?
I'm going to be doing subtracting fractions. and
Not
adding
yet, not
fractions.
yet, sister. Let's hold off on that. You just ready for a problem if I just give you a problem to look at? Yeah, you are, sure. That's the way we want to hear it. All right,
Yeah.
let's take a look at today's problem of the day. I know that we have some of our producers, they put these out on social media. Here's today's math problem of the day. So let's take a look at this together.
Okay.
Bianca bought 954 bottles of water when they were on sale. It must have been a pretty good sale. 954 bottles of water is a lot of water to buy, right?
Yeah.
So if she drank 3 bottles a day, how many days would they last her? So do you have an idea of how to figure out that problem? You don't have to have the answer right now, but how would you go about solving it? Do you have an idea?
I think I'd try and divide 900 or that
Right.
number that they gave us divided by how many bottles she drank a day.
So there was 954 bottles, and she drank 3 bottles a day. So you would do 954 divided by 3. And that would be a very good way to approach that problem. And that's probably the easiest way, and the way that most people would probably go about doing that problem.
Yeah.
So let's take a look at the problem one more time, and let's take a look. Do you think it would be 2,862?
No,
Why not?
because it's bigger than what.
Right, it's bigger than
They
what you
gave
started
us.
with, right? You would have to multiply in order to even get something that high. Let's take a look at the next one. 318, does that seem reasonable, maybe?
Maybe because it's smaller than what they gave us.
Okay, the next one I think was also in the 300s. 364, does that seem reasonable? Because think about 900 and then 3. So think about 900 divided by 3. Do you know what 9 divided by 3 is?
3.
3. And then we have 2 zeros. So if we had 3 and 2 zeros, that would be
300.
300. So the answer's got to be around 300. Does that make sense?
Yes.
Okay. So 318 seems reasonable. 364 seems reasonable. What about 112?
No, because it's not in the 3s.
It's not in the 3s, right? So here's a way for you to solve it without actually having to divide it. Let's take a look at the problem one more time. So it said 954 divided by 3. Now we know that the 954 ends in a 4. So 3 times what will get us to a number that ends in 4? So what's 3 times 1?
3.
3. It doesn't end in 4. What about 3 times 2?
6.
Okay, 3 times 3.
9.
Can you think of anything times 3 where the answer will end in a 4?
Not really.
Let's keep going. What's 3 times 4?
16.
12.
3 times 4 is 12.
That's not ending in a
Yeah.
4. 3 times 5?
3 times 5 is 15.
Not a 4.
No.
3 times 6?
3 times 6 is 18.
Not a 4. 3 times 7?
3 times 7 equals 21.
Not a 4. 3 times 8?
3 times 8, 24.
So we
And that
found
ends
one,
in a
right?
4.
So if we do 3 times something with an 8, it's going to have to end in a 4. So let's take a look at the problem one more time. Which one of those is the answer?
364.
Well, we had to go 3 times what?
8.
And what number up there ends in 8?
318.
318. See, and we didn't have to actually do 954 divided by 3, even though we could. But that's an easy way for you to kind of look at it kind of quickly if you know that little, it's not really a trick, right? Because it's a skill you acquire after a while. But you start thinking, all right, I know I'm going to have to multiply 3 times something. I know the whole number ends in a 4, right? It could have been 64,894. But you know the number ends in a 4. And you know you're going to be using a 3, so you know it's going to have an 8 at the end of the number. Does that make sense kind of a little
Yeah.
bit? All right, good. Well, you know what? There's your first thing for the day. Is that feeling good?
Yeah.
All right. That was today's problem of the day. And thank you to all of you that took a shot at that today on all of our different social media platforms. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Cece and Isley will be working on fractions in a little bit, but first, let's take a look at today's Math in the News. All right, today's Math in the News. Now, did you know that this is the first show of the brand new year, 2023? You were on it. That's pretty cool, isn't it?
Yeah, it's
I
really
mean, not
cool.
everybody can be on the first show for 2023, but you're on it. So Happy New Year.
Thank you.
You're welcome. My pleasure to welcome you and Happy New Year. So Happy New Year. So have you ever heard people say they make New Year's resolutions?
Yeah.
You've heard that before. Do you do that at all?
I don't know what that is.
So it's something where you make up your mind that you want to do something to maybe improve yourself.
Oh, yeah.
Okay. So is there something that you think you might want to work on during the new year?
Probably improving my skills in math.
Okay. So that could be your New Year's resolution, that you want to improve your skills in math. That is an excellent resolution to do. All right. And sometimes adults have things, and sometimes you'll hear people, they go, well, I want to exercise more, or I want to try a diet, or things like that. Okay. Do you think Cece has one? Why don't you ask her?
Do you have one?
I don't. I have a word of the year. And my word this year is fully. I'm going to live pretty fully. That's my goal, is to live fully.
Sound like a good one?
Yeah.
All right. Fully's better than partially or something like that. So fully go
I'm
into that.
going to be trying a lot of new things to figure out what fully means this year to me. But yes, we'll see.
Well, the only way
See
you
how
can
it
figure
goes.
out what it fully means is to fully go into different things.
Right, and just jump on in. Just jumping in.
Which I would have to say is a little different than saying yes to everything.
Correct.
Because that could go
I
down
did
different
have a
pathways
student
right
today
there.
say, well, if you're going to live fully, that means you need to parachute. And I thought, I don't want to jump out of a plane that can land perfectly safely. I have no desire to do that.
So here is New Year's 2023. And a lot of people think, all right, well, it ends in a 3. It's probably a prime number, right? Have you ever heard of prime numbers and composite numbers?
Yeah.
Do you know what they are? Like, can you tell the difference between a prime or composite? Do you know anything that you can tell us about prime and composite? I don't expect you to, but I just figured you're here, so. But you've heard of them before?
Yeah, I've heard of them before.
That's the only thing that I need to know, is that you've heard of them before. So it says 2023 will not be the prime of your life because it's not a prime number. It's divisible by 289.
Because 9 can be divided by 3.
That's a very good way of looking at things. You're close, all right? So let's take a look at the next slide. So prime and composite numbers. So you said that you've heard of these things. Okay, you're in 4th grade. You're going to hear them a little bit more as you continue in 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th grade, all right? So if you understand these now a little bit today, when you start doing them in class, hopefully it'll mean a little bit more to you and you'll be a little bit ahead of the game. Sound good?
Great.
All right, so prime, a whole number that cannot be exactly divided by any whole number other than itself. So the number 2, what numbers can you multiply to get to 2?
1 times 2.
That's it. There's nothing else that you can do, is there?
No.
That's why it's prime. Okay?
Okay.
Now let's look at another one, 5. What 2 numbers can you multiply to get to 5?
1 times 5.
There's no other way to get that, is there?
No.
Right? So let's look at the other side, composite. Composite is when you can multiply other numbers besides 1 and still get that number. So the first one we have is 4. Now I know I can do 1 times 4, but is there another way to get 4 by multiplying?
2 times 2.
2 times 2. That's why it's not prime, it's composite. All right? It's
Okay.
composed of more. All right? Let's look at another. Let's look at the last one, 10. I know I can do 1 times 10. What else can I do?
2 times 5.
2 times 5. Now sometimes people get mixed up. They go, well, a lot of odd numbers are prime. But 9 is an odd number. But it's not prime. Because what can we do?
You can multiply it by 3 times 3.
And what else?
1 times 9.
There we go. So we have a lot of different things, right? So that leads us into our next part, how we know that 2023 is not a prime number. These are called the divisibility rules. Have you ever seen these before?
I think
Honestly,
so.
this is a big, big day for you, young lady, because you are learning so much stuff today. Prime and composite, divisibility rules, how to get numbers on problem of the day, the answers without having to actually do them and stuff like that. So if I said the number 10, is that an even or odd number?
It's an even number.
It's an even number. And what can go into every single even number in the whole world?
2.
2. So there we go. A number is divisible by 2 if the last number is even. Make sense?
Yes.
All right. 3, you can see that, and then we keep on going. So we have all of the numbers between 2 and 10, and we know that 7 goes into 2023 289 times. Now 7 is kind of a tricky one. So we're going to do this together. This is actually your first math problem I'm going to have you start thinking about.
Okay.
All right. So it says remove the last digit. All right. So I'm going to give you the pencil and paper right here. So write down 2023. Now it says remove the last digit. So what is the last number on there?
3.
So cross it off. Okay. Now it says double it. Now what is doubling 3?
6.
6. Okay, so we've doubled it, now we have 6. It says subtract it from the leftover number. Now, if we took 2023 and took the 3 off, what's left?
202.
And that's 202. Now, it says subtract the number that we just got. We had 6, so subtract 6 from that. So
Subtract
go
6 from
202 minus 6. And tell me what you get after that. Right, so that 2 becomes a 12, right? And then that 2, because you had to borrow, becomes a 1, right? So now go ahead and start subtracting. So what'd you get?
196.
196. Now we're going to use the tool. Have you used a calculator before?
Not much, but I do sometimes.
Oh, good. Well, you know what? I know when you get into 6th grade, at least, you're going to be using a calculator a lot. So put in 196 divided by, so you know where the division, 7
It was a long break. It's
7.
okay.
equals,
Equals
and what does it equal?
28.
So that means that the number is divisible by 7. So now clear it and go 2023, 2023,
2023.
divided by 7.
Divided by 7.
And what do you get?
289.
And that's what we said at the beginning, right? 2023 is divisible by 289. It goes in there 7 times,
Yeah.
right? Sound good?
Yeah.
And that is today's Math in the News. So we can see that the year 2023 is not a prime number, even though a lot of people would think so. A lot of people also think 51 is prime because they're like, all right, 5, 50, no,
Yeah.
1, odd, no, it's not going to do it. But that's divisible by 3 because if you take 5 and 1, it adds up to 6. 3 can go into 6, therefore you're all done. Are you ready to work?
Yeah.
Because all you've been doing is kind of hanging out and relaxing all day so far. Over to the board, young lady. Let's get you finally working. So this is some homework. You said you were working on fractions, but you're having a little difficulty. You would like some more practice subtracting
Yes.
them.
Yes.
All right, so let's take a look at the first one we have right here on your paper. It says 9 over 12, 9 twelfths.
Do you want to write it?
Yeah.
Okay. So we're going to turn that around.
Yeah.
So just use your eraser. There you go.
There you go.
So we have 9 twelfths minus 7 twelfths. And then you and Cece can work on that together. And Cece, once she gets an answer, if you need to do anything to it,
Well,
Go into that.
For sure. Okay, so first things first. Let's look at our denominators. Is there something we need to do with them?
No.
Why?
Because they're the same.
They're already the same. Okay, and we know when do we need to have the same denominator? When we add or subtract, right? Okay, so perfect. So we're subtracting. We've already got a common denominator. We're good. So now what do we do? Do we leave the denominator the same or do we subtract the denominator?
We don't subtract the denominator.
We don't subtract the denominator, right? Do you know
Yeah.
why?
Because if we subtract them, they would just equal 0.
Right. We don't want to
And
get
these would be bigger than that.
Right. Well, and part of the problem is that really the question is if I have 9 twelfths, like if I have 9 pieces of a pie that was cut into 12, I'm subtracting what?
7 twelfths?
I'm taking away 7 of those 12ths. So I need to still have some 12ths, right? Okay, so you're right. So we're going to have some 12ths. So go ahead and give us some 12ths and then give us the answer.
How do I do that?
Yeah, go ahead. So just go ahead and give yourself an equal sign. And then give us the answer. What are we going to get? What do we know we have in the denominator? You just told me. What's in the denominator?
7 twelfths?
We have the 12ths in the bottom, yeah. So go ahead and give us that, right? Write that down. Okay. Now, so for subtraction, what do we need to do?
Subtract.
Right. And we get what?
2.
Absolutely. Okay. So far so good. Are we done? Are we all the way done?
I'm assuming in 4th grade with her just starting this,
We're
they're
done?
probably all the way done.
Okay, we're not reducing? You
Not
want me to
yet.
reduce?
We're not going to simplify yet.
Okay, all right.
Let's go on to the next problem.
Okay,
all right.
all
So we're
right.
going to do one more of these.
Okay,
all
I'm
right?
sorry.
So leave
It's
that
fine.
there,
Okay.
and maybe on the other side of the board, Isley, let's write down the next one.
Okay.
So here we go. This is another one on your problem. So we have 4 over 4. So 4 fourths minus 2 fourths.
Okay, so go ahead and just go for it and tell us what you're doing.
So these two don't need to be changed because they're the same. And I would subtract these two. So 4 minus 2 would equal 2. We don't need to subtract the 4, so I'd keep the 4 there.
Good.
So, and 4 minus 2 equals 2.
Excellent. Very nicely done. All right.
And there's one more
Okay.
that has to do with subtraction. So we have 7/8. So maybe go a little bit higher in the middle, maybe. So 7 over 8 minus 4/8.
And then talk us through just like you did the other one.
They're the same, and I just subtract 7 minus 4. And 7 minus 4 would equal 3.
Very nice. Very nice.
So there you go.
Okay.
So that's the beginning. Right now, I
Okay.
think in 4th grade, that's probably all that you're expected to do right now.
Okay.
All right. Nice work for your efforts so far today. You've got yourself a meal from our friends at Grill & Burger, so congratulations on that. When you go, say hi to Lydia, ask if she's there. She loves all of the students that are on Do the Math, and she'll set you up with a great meal. 636-4357 is that phone number. We're going to leave those numbers up there. We're going to do a little something with those in a little bit. But first, we're going to check out some robots at work with the Bakersfield Police Department.
What we have here today is the F6 robot, aluminum base, heavy, about 500 pounds. Instead of sending a human being out to a suspicious package that may be dangerous, that may be an explosive, we use this robot. The way it works, just like your arm would, you have a shoulder down here, you have an elbow, and then a wrist. And then you have your claw, which would mimic your hand, so the claw can open up, and then the claw can close up if you need to grab something. You can extend it out or bring it back in as far as you need. Then you can move the wrist up and down as well. You can move your elbow as well as your shoulder. Now, if you're stuck in a position where you can't move the robot anymore, you can also rotate the torso and just grab something as it's needed. Now it has also these, looks like tracks. We call these articulators. We can put those down. If there's a wall or something high that we need to look over, we can put the articulators down to raise the robot. And with raising the robot, we can also extend this camera. It goes up to about 7 to 8 feet with the articulators down. The camera rotates back and forth as it can. It can do a 360-degree turn. We also have cameras down at the bottom. There's a camera on the wrist by the claw. And there's also one on what we call a pan, percussion actuated non-electric. It shoots water. The big tires that you see here, generally it's made to take down the aisle of an airplane. So we can remove these tires from the outside where we use just the articulators to transport the robot. It runs off of batteries, which are connected down here. We've actually used this on different calls where there's somebody barricaded inside of a residence. We have a microphone here that we can communicate with somebody who is inside of the residence. Hopefully it never happens, but if somebody does go down, we're able to pick up somebody by a shoulder strap or a heavy vest. If we're able to grab a hold of somebody, we can pull somebody that's under 210 pounds and drag them out of the way. A joystick, it looks like an Atari for us older people. And that's how we function and use this robot. There's lots of switches that you have to learn. Every month we train. We do 3 days of training, and this is part of our training. We train with the robot. To be part of the bomb squad, you do have to be selected and cleared by the FBI. You go to 6 weeks in Alabama to go to school to become a technician. And there in school, you learn how to work with this robot and also additional robots that they use throughout the country. The cool thing about being part of the bomb squad is there's only roughly about 3,000 technicians throughout the country, and City of Bakersfield has currently 7 of them.
And there we go, another segment of Robots at Work. And thanks once again to all of the staff and everybody involved with the Bakersfield Police Department. More than hospitable to us, and we got to see some very, very cool things down there and learn a lot down there at the same time. So we will have more from the Bakersfield Police Department coming up this year, but that was the one of their episodes with Robots at Work. We do have phone tutors available until 5:30 this afternoon, and in studio with us, courtesy of the Bakersfield Museum of Art, we have Maria. And how are you today, Maria?
I'm doing great. How are
Nice
you?
to have you in here again with us. And your role with the museum again is?
I'm the Education and Programs Coordinator, so I do a lot of scheduling teachers or scheduling programs at the museum, or also writing some curriculum. So part of the project that we're doing today is something that we've done in our classrooms at the museum.
Okay, and what exactly are you doing today?
We're going to be creating our own stamp. So usually we find stamps that are already created like at Michael's or Hobby Lobby. We're going to make one of a kind with Isley today.
All right, take it away, ladies.
Alrighty, so we're gonna start with our surface area. It's made out of a rubber material. You wanna take off the backing of yours, and that's gonna stick it down on this palette paper, which is really smooth, and then just put it right in the center. And that's gonna help it keep it in place when we're carving out the design. So now we're gonna grab our pencils. You could also grab your eraser in case we have to erase anything. And we're gonna make a circle. So this is gonna be yours. And this is tracing paper. So if you could tell, it's really light. And usually a lot of artists use it when they're tracing over designs that they probably have a lot of detail, but they don't want to do it freehand, so they just go over it. But this is really helpful when we're transferring a design. So we're going to be making a star today. So what you want to do, you want to grab another blank circle, and you want to trace the circumference of it. And it doesn't have to be perfect, as long as it looks like the same size circle. And then just lift it up, and that's your circle. So now you know that you can make your design bigger than the inside of the circle. So we're gonna be making a star. The easiest way for me to make a star is just starting at one side, and then you go down. So it's gonna be a diagonal line. And then you're gonna go across horizontally, and then we're going to make another diagonal line going the opposite direction, and we're going to go down. And then you don't want to press too hard on your paper because it is really thin, so I just ripped through it. And then we're going to connect this last 2 lines to the first line that we started with, so the bottom corner to the top. So that's our star, right? And then the really cool thing about this paper, that when you press it on top of your circle, it's gonna transfer your star. And you wanna press, and you can always use your pencil to help it transfer over. Whatever's easiest. Our hands are always helpful. And then when you lift it, you should have your star on your surface. But we might have to go over it one more time.
Yeah.
So make your star darker. There you go. Okay, let's hold your paper. I know it's really thin paper. Alrighty. Did we get every line?
Not every line.
Do you want the inside or only the outside?
I'll do the inside.
You do the inside. So let's not forget this line and this line. Did we miss any lines?
I don't think so.
Alrighty, so let's try again. And then try to rub it with your, there you go. Good job. Alrighty.
I'm not looking that closely. Did she flip the paper over?
Oh, is that what we're messing? Oh, let's turn it over. There you go. And then now, let's press it down. So we needed to turn it over. And then now, let's try it. So we do have a little bit of a line. And then now we want to make our lines darker. Just so we don't miss those dark lines. See that?
Yep.
Nice work. Alrighty. So now we're going to be using a little bit of a sharp tool. So one of the important things to remember when we're using sharp tools, and we're going to start with that one, we always want to carve away from our body. So when you grab your tool, you want to grab it and put it in the middle of your palm, whichever hand you write with. And then you're going to hold it and you're going to start, and you want to carve away from you. And you don't want to go too deep into the rubber, as long as it just starts taking away from the surface. So we're subtracting from the value of your rubber stamp. And then you just want to take away. And then push. So because it's already stuck to the paper, we don't have to hold it. So it's always good to keep your hand away so you don't poke into your hand. And then use, so if you're carving here, you're gonna carve that way. Do you see that? So if you need to carve in a different direction, then move your hand and then carve that way. You see how that works? All right, do you want to try it?
Which
And then you could
direction
put-
should I go in?
Where do you want to carve?
Either way.
So we want to carve that area out, so we could go this way. And then we also want to carve this corner, right? And you could also, it's really helpful if we move our whole body. So if I'm carving in this direction, then I want to face that way. If I'm carving in this direction, then I want to move my whole body in the other direction. There you go. You're getting it. Just keep going. And try to put this point right into your hand so you use your whole arm, and it's gonna help you really remove all of that part. There you go. And the really cool thing about creating your own stamps is that you're creating something that it's one of a kind. No one else is gonna make it. It's gonna look similar, but because we're making it ourselves, we're putting our own little special touch to our stamps. So we're both making a star, but it's gonna look different, right? Because you're carving your own, and I'm carving mine. And then we could always pick it up and then stamp it so you could carve away from you. So that's a really cool thing about the little rubber surfaces, that they'll stay sticky. So you could,
Which side should I do next?
I would do this side. So we want to keep the little point. So we're going to carve outside. There you go. And then if you're going too deep, try to pick it up. So we want to keep this area. Right? Because we want to make sure that it looks like a star. So you could take all of the surface, and sometimes using your pencil is always our best friend. So all of that area that I'm coloring in, we want to remove it. We want to take it away.
Okay.
Okay. And then as more comfortable you become with the tool, you'll start getting a little bit faster. But it is different from drawing or painting because it's a completely different tool. So it's okay if you take it a little bit slower, and then once you get comfortable, we could go faster. And then remember to don't get too close to your other hand so we don't get hurt. Okay. Alrighty. And then I'm gonna start setting out the paint while you finish your stamp, so we could use it too. So we're using a specific paint for stamping, and this is a little bit more when we have artists that create really big stamps. We want to use an acrylic based paint that is thicker.
You need me to get Cece over there and open that paint for you? She's got the biggest muscles on here, so.
Right. I doubt it, but here we go. I was gonna say I'll try the blue. I think I would have just stuck it with a pencil by now.
That's probably the smartest thing, yeah.
The only thing you don't want to do is open that up so much and then it comes splattering all over your
I know.
shirt.
I'm like, you got another shirt for me? Because this one is not cooperating.
Well, how about if you ladies just use the blue one for
Yeah.
now?
We
We'll
could use the
just-
blue, yes.
Yeah,
So,
that's not
it's
happening.
really thick, as you guys could see. And we want to make sure it's not liquidy, so it doesn't just like spread everywhere. We want it to be a really solid consistency. So the paper that we have here on the table is palette paper. So it has sort of like a glossy surface. So the paint's gonna work really well with us. And then we have a roller where we grab a little bit of paint, and then what we want is just roll out the paint to where it's all over the roller. So there's still black spots. We'll grab more paint and then roll it. And then once we hear that sort of like sticky sound, then we know the paint's ready to be rolled on our stamp. So we'll check how your stamp's going. Do you think you're ready for the paint?
I
Should
think
we
I
try
should
it?
just do a little bit more.
Okay, a little bit more. Then I'll get your roller ready.
Bottom of the
And we'll do the
star.
same thing. And if anyone at home is trying to look up the paint, it's called printmaking ink, but it's just an acrylic base. So I think most of us have used acrylic. It dries really fast, and that's what we want when we're doing stamps, because we don't want them to smudge all over our surface.
I just have to do this a little bit.
Okay, so we're getting close.
Okay, that's probably good.
Alrighty, so we'll clean our surface a little bit, and then you want to grab your roller. So you could grab your roller. It's all ready, and we want to roll it on top of our stamp. There you go. And then once it's all blue, you're gonna grab your white paper that's right next to you, and we could put back the roller on the machine. And wherever you want to put your stamp, I always like to start in the center to see what it looks like, and then you just want to place your paper on top and then press with the palm of your hand. You want to press a few times just to make sure the design transfers over. And then you just lift your paper, and then you'll have a stamp. And then the cool thing about stamps, once you create it, you could go back and add more paint, and you could create a pattern that repeats over and over again. There you go.
So Maria, while Isley is doing that again, starting to make a pattern and a sequence of those right there, the math that you were doing is you have a value and you're subtracting from that today.
Yes.
And once again, if some students or teachers or parents wanted to find out a little bit more about the museum and the activities that you have down there, where would they need to go to?
So online, our website, it's bmoa.org. And we have already classes for Saturday Studio where we host the classes in our classrooms. We have 2, and we really try to experiment with new mediums, and we love to be inspired by the work that we show in the museum. So we try to give them a little walkthrough to some of the pieces that we have in the museum so the students are inspired by the work, and then they go on into the classroom to create their own piece.
All right, nicely done. And once again, if there are any educators out there and they need to get a hold of you, you would be the one because you are in charge of all the education
Yes,
down there.
I
So
would be the
Maria is the person at the Museum of Art. Thank you once again for coming in. And hey, you know what? We'll get Isley working on some more math right after this.
Good job.
I'm Kira Mizell. I'm a research oceanographer in the Pacific Coastal and Marine Science Center in Santa Cruz, California. I think as humans, we live on land and we think about climate a lot in terms of what's happening on land where we live, but the ocean plays a really big role in climate, both in how climate is affected and effects of climate on the ocean system. I study a particular kind of deposit called ferromanganese crusts, and they're a deep ocean mineral deposit that grows really slowly by precipitating from seawater, and precipitating meaning little bits of solid mineral material forming and accumulating in these layered deposits over millions of years. And we can look at those deposits and learn about the chemistry of the oceans way back in the history of Earth. I really like that ferromanganese crusts especially are very widespread throughout the seafloor. A huge part of our Earth is covered in seafloor. We focus on the land part, but a lot of it is ocean floor. And I think we think about the ocean as being a big giant bathtub and that not a lot is changing over time. But everywhere that these crusts are growing, each one that we pull up has a different story to tell about ocean chemistry, about elements, and how they're being dissolved into seawater and accumulating over millions of years. And so I really love that these black rocks that just look like blobs that are covering the seafloor and underwater mountains that we call seamounts, that maybe they're not so interesting, but every single one is telling a story.
I'm Mike Carey. I'm a research fish biologist with USGS Alaska Science Center. As I say, I'm a fish biologist, but I'm really an aquatic ecologist that happens to be interested in fish. Beavers that used to be in their historic range, they've migrated northwest out of the boreal forest into the tundra. And now they're building these large dams and dam complexes in tundra streams. So we've gotten interested in understanding what that means for the ecosystems, thinking about how the impounded water is going to change the hydrology of the system, how the impounded water is going to exacerbate the permafrost thaw. And ultimately, what I'm interested in as a research fish biologist is understanding what that means for the aquatic food web and fish that use these systems. Fish are a great tool because they sort of integrate all of these changes, right? They respond to the environment in a big way. They also happen to be pretty important to people. So it's a great tool to assess these landscape disturbances, kind of looking at the landscape dynamics. And there's been a lot of really good research in the lower 48 on beavers, so we know a lot about what's happening. But what I think makes it sort of a unique and novel thing is it's outside of the historic range and interacting with permafrost and permafrost thaw, which is increasing due to climate changes. So all of a sudden we've got these systems that we've been studying, trying to understand, and which can act as the control. And then we look over to the other valley, across the way to the next watershed, and there's beavers changing things. And it's like, what a great design to be able to infer some of these big effects in a novel system where they haven't been before.
I'm Heather Johnson. I'm a research wildlife biologist with the USGS Alaska Science Center in Anchorage, Alaska. And my research program right now mostly focuses on caribou in the Arctic. Arctic caribou exhibit the longest terrestrial migrations of any animal on Earth. They cover huge landscapes, ranging over areas the size of states in the lower 48. Caribou in the Arctic are incredibly important. Ecologically, they're important because they are the primary large herbivore in the Arctic. But they're also really important as a subsistence resource for people that live up in these remote Arctic landscapes. So we're collecting lots of different data types on caribou, but one of the things we do is we catch them and put collars out on them. The collars collect GPS locations of where they go and how they travel and use the landscape. But they also are collecting videos. So on the collar is a camera that sits below the caribou's chin, and it collects a video clip every 20 minutes or so. And so we really get to see life from a caribou's perspective. So a lot of my research focused on caribou in the Arctic is trying to understand how climate change is affecting habitat conditions. The conditions we know are important for caribou, so things like forage in the summertime or insect harassment. And then we're also trying to understand how caribou are responding to those changing conditions. And then with that, be able to hopefully predict how populations might respond to future environmental change. What's really important to me is that we get to use the research and get to apply it to manage and conserve these populations.
And once again, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays. A big thanks to Maria and the Bakersfield Museum of Art for that great lesson on stamp making and subtracting from the total value. In studio with us, we have fourth grade student from Stockdale Elementary, Isley, who's been working on subtracting fractions. And we're going to go another step into what she'll be doing in fifth grade. So ladies, back over to the board.
Okay, so we're gonna, now I kept saying the word reduce. Do you know what it means to reduce? Just a random English word, if I said you're going to reduce something, you say...
You're going to make it smaller?
I'm going to make it smaller. Okay, now we're going to kind of go backwards. We're going to make it bigger for just a little bit. And what I mean by make it bigger is we're not going to change the value, we're just going to change the denominator. Okay, so now just watch me for just a second, and then I'm going to have you jump in. Okay, so here's my pi, right? When you talk about fractions, a lot of times they use pies, right? Okay, so here we go. We've got a whole one. Right? Okay, so if I break this into even pieces, what am I going to do? Like, I can do a whole bunch of different pieces, right? That's what we talk about, the 12ths and the 4ths and the 8ths and all that, right? It's all equal pieces. Okay, so what's my smallest equal amounts I could break it into?
The smallest you could break it into is probably like...
What if I did this? If I did this, what is that?
That's a half?
Right, I have a half on this side, and I have a half on this side, right? Okay, so now if I break these into equal pieces, what's going to happen?
Then you're going to get fourths.
I'm going to get fourths, right? Okay, so I have now 1/4, and 1/4, and 1/4, and 1/4. Okay, what happens if I break these into equal pieces?
They're going to equal 6.
So if I break them all into equal pieces, I do this, so now I have my equal pieces. How many pieces is this?
6.
So we'll start here. 1, 2, 3, 4,
5, 6, 7, 8.
So what do I have? 8s. Okay, so I have 1/8, and I'm kind of running out of places to write this, but I'm going to just give myself 1/8. Okay, so the reason I'm going to do this is because. Okay, so I have 1/8, but I did have 1/4 here, and I had the halves going all the way through, right? Okay, so now if I were to, I'm going to change to this one just because this is a different color. If I go ahead and I color in this one here, and I color in this one here, what would I call this? Do you know what I would call this? I just colored in how many of my 8ths?
2/8?
I colored in 2/8. What else did I color in? How else could I call this? What else could I call this? Instead of 2/8, I also colored in this portion, right? And what is this called?
A quarter?
It's a quarter, or
1/4?
1/4. So 2/8 is the same as 1/4, right? So how do I show that something's the same? I use what symbol?
Less than
Not making them the same though, because they're the same, so it's
equal.
absolutely. Okay, so it's equal. So I know that 2/8 is the same as 1/4. So is that true? Like if I look at
Yes.
this, I'm saying that's true?
Yes.
Okay, right. Okay, so now what happens if I go ahead and I say, okay, I'm going to color in here. Okay, what do I know? How many 8ths do I have?
4/8?
I have 4/8. How many 4ths do I have? So there was my 1/4. Here's another 4th. How many 4ths do I have?
2/4.
I do have 2/4. What else do I have?
You also have a half.
I have a half. Okay, so if I look at this and I go, okay, well 2/8 was the same as 1/4. 4/8 is the same as 2/4, which is the same as 1/2. Does any of this look kind of like you've seen any of this before? Does any of this sort of like, have you seen?
No,
Not so much, but does this make sense?
Yes.
Okay, so now here's the thing. We can use multiplication in order to make our denominators bigger, and we can use division to make our denominators smaller. Okay, so if I were going to make my denominators bigger, so I'm going this way, 4 times what gives me 8?
2.
Times 2. Times 2. So if I multiply by 2, I get to my 8. If I multiply by 2, what do I get?
4.
1 times 2, oh, sorry, it's up here. 2, right, okay, sorry, it was a little more obvious than that. Okay, so I know this, that I can go in between 1/4 and 2/8, 2/8 and 1/4, because they are both divisible or multiplied by 2. Okay, same thing here, look at this. If I go here, times 2, times 2. But if I said I wanted to go straight to 8 from 1/2 to 8, what would I multiply by?
4.
Absolutely, I would multiply by 4. And if I did that, then I know my numerator I need to multiply by
4.
Absolutely. So I'm going to do the same thing and same thing. Okay, so I know that as long as I'm multiplying by 4 over 4, I'm going to ask you one more question. What is that?
4/4 or 1/4?
1 whole. Okay, so what is anything times 1? What's 3 times 1?
3.
What's 100 times 1?
100.
What's 1024 times 1?
1024.
Right, okay, so we know that anything times 1 is the same. Anything divided by 1 is, so like if I have 12 divided by 1, it's
1.
12 divided by 1 is going to be a 12.
12.
They're right, okay, 4 divided by 1 is
4.
So anything divided by 1 is itself. So that's why this works, that as long as we multiply the same thing and the same thing, top and bottom, just like that, we're doing it by 1, and it's the same thing, right? So just because it looks different, it doesn't matter that it looks different. It's exactly the same thing, which we just saw in the picture. So let's look at this problem right here. We ended up with an answer of 2/4. That's not the reduced form. So we went bigger, we got things bigger. We're now going to make things smaller. We want to go to the smallest form we can have, okay? So if I look at 2/4, if I look at the 2 and the 4, what can both be divided by?
2.
Absolutely. So go ahead and show me a divided by 2 and a divided by 2. Okay, and then we're going to try and squeeze it in right here. We're going to do an equal sign, and then we're going to say, so 2 divided by 2 is
1.
1, and 4 divided by 2 is?
2.
Okay, so give yourself a fraction bar. So we know that 2/4 is equal to 1/2. And now can we reduce that? Can we make it any smaller? Can we make the 2 any smaller?
No.
No. Okay. All right. Now we're going to go again. How about this one here? 2/12. What are both of them divisible by?
2.
Perfect. Do it. So 1/, and so we know that 2/12 is the same thing as 1/6. So if I took a piece of pie, or I took a big pie and cut it into 12 pieces and had 2 of them, that would be the same thing as looking at 1/6 of them. Now, if I look at 3/8, can I reduce that one?
No.
Why?
Because 8 and 3 can't both divide by 2.
Okay.
Well, 8 can, but 3 can't.
Right. So, and it's not, we're not always worried about it being divisible by 2. We could divide it by 6 or 12, but it has to be what?
Even.
Because it has to be the same thing. So as long as if the 3 and the 8 could be divided by the same thing, we could reduce, but they can't. So we're done. Because 3 is a what kind of number from the beginning of the show? Is it prime or composite?
Composite.
Okay, so composite is the one that can be divided by a lot of different things.
And
Prime is the one that's only divisible by
1.
1 and itself. So 3 is a prime, and 8 is a
composite.
is. High five. Nicely done.
Nicely done. So simplifying, we're going to take a look at something else because you've done subtracting, but now we're going to take 1 minute and look at addition. Okay?
So go ahead and
So
put
we
this
have
one on the board.
2/3, 2/3, plus 1/3. And what I'd like you to do is when you're done with that, simplify it, because simplify works when you were getting, so reducing is different because you're actually taking something away, right? So simplify it, even though that's what you were doing before. You're going to simplify going the opposite way now.
Aha, she already knows. She's got it.
And how did you know that already?
Because 3/3 is equal to 1.
That's the whole thing, isn't it? Okay. So let's try this. What's 3/6? Can you simplify that? So go ahead and write 3/6.
Here, let's give you a space. Okay, do it again. 3/6.
And can you simplify that?
No.
So again, the question is, can they both be divisible by the same thing? So what divides into 3?
1. 3
And?
times 1.
And? So 1, and what else can divide into 3? You were saying it in the multiplication form. What were you saying? It's what times what gives me 3?
9?
No,
3
sorry.
times 2 is 9.
What times what gives me the answer of 3?
3 times 1.
3 times 1. So then that's it, right? Because it's a prime number. Okay. So we know that 3 divided by 1 gives us 3, and 3 divided by 3 gives us
1.
1. Okay. How about 6? What can we divide into 6?
1 times 6. 2 times 3.
Ah, all right. So what number divides both into 3 and into 6?
There you go, the 3 into both of them, so then you come up with 1/2. Nicely done, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.